It's Monday, July 6, 2015, and you're listening to the Armchair Atheism podcast. I'm your host, Taylor Carr, and for this episode our topic of discussion is the origin of the universe. What does science currently say about the history of our cosmos as we trace things back far into the past? Is such a scientific view of our universe compatible with a religious worldview? Does the Big Bang actually support a creation out of nothing and thereby lend credence to theism? I speak with physicist and author Aaron Adair about some of these questions and more in this episode of Armchair Atheism. Aaron Adair is assistant professor of physics at Merrimack College in Massachusetts. He earned his Ph.D. and Masters from Ohio State University and his Bachelor's from Michigan State University, and is the author of a 2013 book called The Star of Bethlehem, A Skeptical View. Aaron, welcome to the show.
Thank you for having me here. It's a pleasure.
So first off, it would be interesting to start off with what was your inspiration to study physics? Was there any kind of a awe towards science or anything like the scientific worldview that motivated you in that direction?
From what I remember from when I was younger with like the fictions I used to watch and such, I somehow always felt attracted to the characters and the things that were always dealing with the natural world. Like, for example, when I was young, I was a big Ghostbusters freak, and I would want to be, of all the characters, Egon. Why do I not want to be Bill Murray? I don't know. Something was wrong with me as a kid, apparently. But just in general, the sciences were interesting to me, and probably also one big influence I remember a lot was like Back to the Future. I'm an 80s kid, so these are the things that are messing with me. And I think ultimately I transitioned to wanting to do specifically things in like physics and astronomy when I was discovering things like Star Wars and Star Trek influencing me. In the 90s you had like events like Comet Hale-Bopp going over, and I had a beautiful view of that from my home. I just knew that this was the thing I wanted to know about, and especially since astronomy is such a, well, to be a bad pun, a big subject and has such big questions attached to it. That's what I really wanted to get to, those sorts of fundamental things about life, the universe, and everything.
Have you ever been religious, or how did that factor in much at all in some of your interest in physics?
Well, while I come from a family that is Catholic in its origins or relations, it's never really been that big a deal in my life. I mean, while I was quote-unquote Catholic, I'd probably call myself a Catholic deist. It was kind of just in the background, and for the most part it would just mean what I'm doing during Christmas and how many times I might be praying when my grandparents are around. I mean, I had gone through communion and things like that, but I was never devout, and when I left religion in my college years, it was hardly a major transition. It didn't really influence me one way or the other when it came to my interest in the sciences. Unfortunately, my parents were very willing to encourage my endeavors in the sciences.
Well, that sounds pretty cool. So it sounds like you were more culturally religious in that sense, I guess, which I'd be willing to bet seems like it's kind of a common thing among some of the major scientists who are also religious.
True for some, and especially if they're from a Catholic background. I mean, the term Catholic, cafeteria Catholic is one that comes up a lot, where you go to the buffet line, you pick what you want.
So, since this episode, I was thinking that the topic for this that we could cover would maybe be some about origins and cosmology, and maybe you can start off by giving us a brief outline of the current standard model as it's known in cosmology.
Well, you really don't need me too much for that, because it's all nicely introduced by the Bare Naked Ladies, and it's at the beginning of the Big Bang Theory every week, so just watch CBS. Okay, you probably want a little more detail. Alright, so the current consensus amongst astronomers, and specifically the people who will study this, cosmologists, is that our universe, our observable universe, can be traced back to a state 13.7 billion years ago. And in case you have any British listeners, 13.7 thousand million years ago. So obviously way farther back in time than humans had ever previously imagined. And at this extremely early state, everything that we knew, whether it be planets, dust, light, everything is compacted to a region of virtually no size. And from that, it expands at a tremendous rate in an event which was been called the Big Bang, even though it actually got that name from one of the opponents of this hypothesis back in the 40s. This is expanding ultimately because when you have anything that's hot, it wants to kind of spread out. And so this is the early state of our universe. It's of the most immense temperatures possible. In this early state, it's also forming the earliest nuclei for the atoms that will eventually grow, mostly hydrogen, helium, a little bit of lithium. And this universe remains amazingly hot and opaque. You wouldn't be able to even see through the universe at this state because any photon trying to bounce around would be hitting another charged particle like a proton or electron. So literally it would be extremely hot and cloudy. You would be able to see pretty much nothing. And this, of course, assuming you could be held together. It's so hot you'd just be plasma. There is no you. Eventually, though, the universe is expanding enough and it cools down, releases out, and then the universe is dark for millions of years. And after quite some time after that, there is at least some areas of this extremely dark universe that are denser than others and start to collapse some of those primordial gases together. And eventually those gas clouds become large enough and collapse to produce the first stars, forming the first galaxies. And this process all over tens and hundreds of millions and even billions of years until we finally, of course, get to the origins of our own solar system about 4.5 billion years ago. So that's the very broad picture what we have from basically almost an instant fraction from the very beginning of the universe to about now.
So are there any serious competitors to the standard model or to the Big Bang?
Well, there are a few scientists who do take seriously alternatives to it, but when I say a few scientists, I'm literally talking like 2 or 3. There are some of the last proponents of what had been called the steady state theory. And basically what's going on is, well, after Albert Einstein comes out with his general theory of relativity and it's being applied to the universe as a whole, 2 major camps are basically emerging. One is that the universe has some sort of origin point that you can trace back around, some tens of billion years ago. And the other proposal is that, well, the universe has always existed in some form indefinitely far into the past, that there would be no Big Bang. This steady state theory is usually attached to the astronomer and physicist Fred Hoyle, who, while he gets associated with this and other things that are a little bit weirdly connected to panspermia, he was an absolute genius and did some really important things when it came to like modeling the sun and solar fusion and things like that. Really important stuff there. But ultimately, the evidences that came in from the 50s, 60s, 70s, and building up as time went on basically made the steady state theory pretty much impossible to hold on to without bringing in all sorts of ad hoc explanations. And later we'll talk about what sorts of evidences exist, so it's not just our priesthood of cosmologists saying what's on high true. And we got a revelation in the 60s. Not quite the same. But like I say, the only people left who have been pushing the steady state model of some form have been some of the students of Fred Hoyle. And they still don't seem to stack up well the evidence. They need a lot of ad hoc additions. And when I've sat in amongst other astronomers in like their coffee sessions, they brought up one of those papers and just quite literally laugh at it.
What are some of their motivations behind still sticking with the steady state model? Because I've heard some speculation that Fred Hoyle's one of his main reasons for preferring it was because he didn't like the idea of a beginning to the universe, which he thinks that the Big Bang, as far as I know, he thinks that the Big Bang was evidence for a beginning to the universe.
Yeah, it definitely struck him as some form of creationism. So that was unattractive, and I mean, heck, even Aristotle thought that it was the only logical conclusion that the universe always existed. You're going from nothing to, bam, a universe seems to boggle the mind. It doesn't seem at all plausible. So I definitely get that feeling, and I mean, that same sort of intuition in some ways makes other people want to say the same thing. Well, you can't go from nothing to something. So that gives you either the options of something always existed, or something magical of some sort. And, usually in physics we want to minimize magic man done it, or hocus pocus. We want to keep that to a minimum, except when our experiments don't work. Then it's always magic.
So what are some of the lines of evidence that do support the Big Bang model?
Well, one of the things is that you'll notice that if you have a amazingly good telescope, if you have access to the Hubble, which you might have to have a little bit of money to have access to that, but one of the things you're going to notice that as you look further and further away, you're looking further back in time. And when you're looking further back in time, the universe doesn't look the same. If the universe had always existed in some form, or if in Hoyle's model of a steady state system where matter is constantly being created at some regular rate, then pretty much everywhere else in the universe you'd expect to look, about as aged. You wouldn't expect, for example, one of the ways we can tell the age of stars is what they have is what they're called their metallicity. And for astronomers, metal is any element heavier than helium. So oxygen is a metal. I know that makes no sense to the chemists, but astronomers apparently don't care about chemists or mean like that. But like, for example, stars that tend to be younger or come from earlier patches, have lower metallicities, and older stars that are later generation stars. Our sun, for example, is a later generation star in the Milky Way galaxy. But we look really deep into the past, we don't see that sort of thing. The various radio sources that we see only seem to exist in, like quasars, for example, seem to be like proto-galaxies, but you only find them when you look really far into the past. So already there's almost like some sort of like age feature that you could see to the universe. One of the things also we can see is what is like the constituents of the universe, like what's it mostly made of. In the Big Bang model, in that you basically have virtually all the hydrogen and helium in the universe, especially the hydrogen, all forming then. And we can, very well model how much hydrogen and helium should be produced from those initial conditions of starting from an extremely tiny point and then expanding, cooling down, and then releasing all the materials in that process. It makes very robust predictions about how much hydrogen, helium, and such there should be, and of course how much the stars should have produced of the various heavier elements with time, even though the stars barely touch on how much hydrogen and helium there is in total. Since the universe is mostly kind of like empty space, and not most of the hydrogen is actually going to even fuse, even when a star like the sun finally dies, there's still going to be a lot of hydrogen left over. So we can project back reasonably well how much there was back then. It fits well with what Big Bang Theory would predict. Nothing so well for a steady state model, unless again you just want to make it ad hoc fit whatever data you want. Probably the biggest piece of evidence that will be pointed to is the cosmic microwave background, or CMB. This is the idea that before, when I was giving the picture, you originally had this extremely hot state, and because the universe is so hot, so dense, and you have nothing but ions zipping around, no light can travel any significant distance. Everything looks like it's cloudy. But once the universe is finally cooled down, it can finally allow all of those photons to just travel out in every direction. And as time goes on, those photons are basically filling up more of the universe. The universe itself is cooling down. And so what you would expect to see is all that light being released and then being this very uniform or reasonably uniform background over everywhere you would see in the sky. This was then somewhat accidentally discovered in the 1960s, if I remember correctly, with the radio telescope, and accidentally in part because the astronomers who had first detected it thought there was something wrong with their telescope because they kept pointing their telescope in every direction and getting this sort of staticky background. And after testing their instruments and trying to clean out the inside of the telescope, thinking it was just bird poo that was giving them their signal, just very rigorously trying to clean things down, and kept getting this. They finally, of course, talked to another cosmologist and say, "Oh yeah, that's something we predicted like a while back. You found it? Holy crap!"
It's kind of interesting because one of the things that I used to hear when I was more religious, and I shudder to even say it, but once upon a time when I was a creationist, I used to hear people talk about how some of these views, these models, are kind of constructed specifically to deny the existence of a god. But one of the things that I find really interesting and problematic about that view is stuff like you just mentioned, like the discovery of the cosmic microwave background radiation, which kind of sounds like it was pretty much an accident. It wasn't like some conspiracy from atheistic scientists trying to come up with a theory to disprove the existence of God.
Yeah, you could even go back further than that, like when Einstein had proposed general relativity, and then it was shown pretty quickly that, this theory basically says that the universe can't be stable. It's going to either expand in size or collapse down. And Einstein, thinking that, the universe, again, should be some sort of eternal state somehow, putting in a term into his equation to basically just hold up the universe and just, keep it steady indefinitely. And then Hubble making his discoveries and then making Einstein say, oops. Again, going from, basically having a universe with no creating point or no apparent origin point to, oh, the universe is expanding, and this opens the door for some sort of early origin for the observable universe. So if anything, astronomers have been slower to jumping on the creation of the universe bandwagon.
Yeah, that actually segues pretty nicely into something else I wanted to bring up. Like I mentioned, there's some religious believers that have seen the Big Bang as kind of like the atheistic alternative to the biblical creation story. And Stephen Hawking has become pretty well known now for arguing that the Big Bang is just a consequence of the laws of physics, and God is pretty much therefore an unnecessary explanation. So how do you see the scientific side of the origins debate, and what kind of a relation do you see it having? Is there such a thing as compatibility between a religious worldview and something like the standard model of physics at this point?
I think there's two interesting angles to approach this sort of question. One, historically, like, is it really the case that there's been this atheist cabal that is looking for any possible way to get rid of God? And other than the shadow government really running the universe. Again, with the history of it, like, again, Einstein was originally, not hopping on board with that. And one of the early proposers of the Big Bang model, or, as he used different terminology, it was a Jesuit priest and astrophysicist, Georges Lemaitre, a Belgian priest, if I remember correctly. And his proposal that he wrote about and he published about in Nature back in the 30s was this origin from a cosmic egg or a primordial atom was the terminology he used. And like I say, this was a Roman Catholic, who originated, in many ways, the Big Bang theory, in its earliest forms at least. While on the other hand, Fred Hoyle, who was an atheist, didn't like this sort of thing, and he gave it the name the Big Bang Theory because he was trying to disparage it. So really, if anything, you could argue is that atheism was getting in the way of accepting the Big Bang Theory. You could actually argue that instead of, it being Christianity getting in the way of, believing evolution, it's atheism getting in the way of believing cosmology. You could have made that argument, but instead, you're right, there are other folks who will attack the Big Bang model and say, yeah, it's those atheists trying to get rid of God. And on a philosophical point, even, this just falling apart on history, on just a philosophical point, if any time we explain something with science that's taking out God, well, does that mean we also have to be browbeaten by religious people when we explain lightning or basic weather patterns? If any time we explain something without God, does that actually make us, trying to take out, the divine in our world? It seems like basically it's not an argument against a particular science. That is an argument against the totality of science. So it seems philosophically, frightening if someone makes an argument like that.
Yeah, I think what's interesting to me is Stephen Hawking, what he said as far as I've understood it, which granted, I probably don't understand it anywhere nearly as well as he does, but from what I've understood, just the argument that he makes that God is an unnecessary component to an explanation for the scientific origins of the universe, I can kind of understand that. I think, like, where a lot of the problem comes in is, speaking of philosophy, he's been kind of well known as a critic of philosophy, kind of asserting that it's dead. But then that still raises the problem, the age-old problem of something from nothing. And it's interesting to me because that seems to have been, as far back as I can remember, one of the big criticisms of the Big Bang was that from theists saying that it's teaching that something can just pop out of existence from nothing. But one of the things that's always puzzled me a little bit about that was that they think that somehow God can do that, which, even if you believe he's all-powerful, it still leaves the question completely unanswered of how you can bring something out of nothing. So it seems to me like there's some confusion and some unsettled questions there on both sides. But
yes,
then,
yeah, they definitely want to go, if they want to really, have God create ex nihilo out of nothing at all, rather than him being like the demiurge of Plato and there's just all this primordial matter around and he makes a universe out of it. At least then you wouldn't have that conundrum and a straight up contradiction from nothing comes out of nothing.
Yeah. So there have been actually a lot of apologists more recently. It seems to me like it's been maybe the last 30, 40 years or so, but a move among a lot of Christian apologists, especially claiming that the Big Bang is actually evidence for a beginning of the universe and for a creator. Is there some sense in which the Big Bang can accurately be called a beginning to the universe, though, especially when it's thought of as the expansion of space and time?
Gets a little bit confusing in part because the way that astronomers will use the word universe isn't necessarily the same every time because there's a bit of a shorthand. When we're talking about basically the universe that we're making our observations and measurements about and what we're talking about the fate of, we're usually talking about what would be the, quote, observable universe. And that isn't the totality of, quote, universe. That there's going to be actually parts of the universe that are completely unobservable because they're actually too far away. And there's also the possibility that the sorts of things that our observable universe emerge from produce other universes completely separate from ourselves. So there's also some ambiguity with the language if you're just reading, like, say, a popular cosmology book, because the astronomers usually aren't going to be verbose and specify exactly what universe they mean every time, because they're not being paid by the word, I guess. If this was a 19th century textbook, maybe it'd be different. I don't know. So besides that confusion, though, while the observable universe seems to, have begun around 13.7 billion years ago, we cannot really say to know what had happened before then. This is in part because, while the Big Bang Theory is great at basically saying everything that's happening like an instant after time zero, we definitely don't know what happens around that point because we actually don't have, at this point, a working model of quantum gravity. We have the gravity that's explained by general relativity that Einstein came up with in the 1910s, but we also believe that it's not going to be the ultimate theory of gravity because it should also have a quantum interpretation on these smallest scales. And the way of reconciling that has so far been incomplete. String theory has, of course, been one of the popular theories in the media, talking about a way of doing that, but even there, it's still not anywhere near a done deal. So, since we don't even have that theory, we have no way of saying with any certainty, even if there was a before the Big Bang, or significantly before the Big Bang, if it would go on indefinitely, if there was absolutely nothing before then, and of course, then we get into the nice philosophically hairy question of what is nothing. So, if we wanted to be honest, we'd have to actually say we don't know if the universe cannot be in any way projected back indefinitely with time. We have to leave all those options open even now.
Yeah, one of the issues that I seem to see come up again and again, especially in these debates over the beginning of the universe and the implications of modern cosmology, is the very question of how one is understanding and defining time. Maybe you can talk a little bit about that. And is there much thought in the way of maybe any advancements in quantum physics or quantum mechanics actually like changing the definition of time?
Well, there's actually even some physicists who want to argue that time is not a fundamental thing in the universe. that it might actually be an emergent phenomenon from other things. Granted, I have virtually no ability to have an intuitive feel for what that is supposed to be like, of how this ingrained feeling of time is actually derivative of something else that is somehow then not temporal. I mean, it's almost, the weirdness of talking about change and yet time not being a thing. It's, believe me, my brain doesn't quite process it that well. But I would think, for the most part, most physicists are basically saying, well, whether time is real or not, this is how we're going to play with it. We're going to use our equations. We're going to take calculus derivatives based on time. Why? Because they work really well. But we do have to take seriously that maybe somehow a quantum interpretation of ultimately gravity, which, since gravity is explained by space-time, that could indeed make time totally different than what we currently understand it to be. In the meantime, though, sorry to use the bad terminology there, we have a theory that works, and it's probably the best way we can approach questions of origins, unless we, keep running and finding that they lead either to contradictions, quandaries, or just some sort of weird paradoxes that we can't get around unless we realize, oh, we're just running from a bad definition. I, of course, don't know how to best approach that, other than, of course, noticing that it so far has worked really well in regulating our lives and our physics, and any changes to it is going to have to still, explain the same phenomena. So whatever replaces it, I don't know if that would even necessarily get us past the conundrums of, does it make sense to talk about before the beginning of time?
Yeah, that's, I guess it would also make sense. That's one of the main objections I've heard raised to something like the Kalam cosmological argument, is this whole idea of a beginning before time seems just confusing, because, I mean, events are supposed to take place in time, and so a beginning before the beginning of time would just not make a whole lot of sense. But then it raises, I guess, another issue of, if you're talking about time maybe before time, that's still something that it seems like you'd have to have some evidence or some reason for believing would exist. And so I guess at this point it still seems like, even if there's a chance that that our conception of time could change in light of new evidence, that's kind of something that's still forthcoming that we can't really rely on at this point.
Yeah, at least from, say, the pure physics of it. On the other hand, I guess it also is somewhat approachable, whether you're going with, say, for philosophy of time, you're taking a tensed or a tenseless theory of time, the A or B theories of time. The B theory being actually more consistent with special relativity, and where I tend to put my money. But other proponents, especially the main proponents of the Kalam cosmological argument, go with a tense theory of time, both for the intuitive feel of it to explain the flow of time, and also because apparently the Kalam cosmological argument requires the A theory of time. So that B theory has to be wrong. And, well, what does Einstein know about time anyways?
Well, speaking of the Kalam argument, Christian apologist William Lane Craig has made a whole lot of this theorem called, I think it's pronounced Borde-Guth-Vilenkin. I may be butchering that. But he's made a whole lot of this theorem in his debates and published work, basically declaring that it, in his view, settles the question of an origin of the universe. So can you talk a bit about this theorem and what it is that it suggests?
Sure. So Borde-Guth-Vilenkin, I'm certain about how to pronounce Guth's name because he's a very important physicist in cosmology. He was actually the originator, or one of the main originators of the theory of inflation, which is this other extremely early phase of the universe right after the Big Bang. And I want to highlight this in part because actually Craig, who you mentioned, has, in at least previous works, basically tried arguing that inflation is a false theory. So I find somewhat ironic that he, of course, brings up the same theorem, which is ultimately about inflation and its limitations then. And part of why he may not like inflation we might want to talk about later, because it's ultimately part of the explanation that Stephen Hawking and others use to say, well, how you can have a universe pop out of nothing. But we'll we'll jump to that a little bit later, but for your question for what the Borde-Guth-Vilenkin theorem is supposed to do is to say, okay, in the theory of inflation, you basically are having this field that is ultimately causing exponential expansions of regions of the universe, or the entire universes. And the system is ultimately eternal. Once it gets started, it'll keep going, or regions of the universe will pop into the right quantum phase, so it'll expand and keep producing little universes like that. It's usually quite chaotic, and so you can project this forward indefinitely and just have infinitely expanding universes all over the place. All right, then the question is, okay, well, could we project that backwards? In which case, then, we have some sort of eternal inflationary universe. So what the three physicists who you were named in that theorem did is basically say, all right, well, if we project back inflation using the same equations of general relativity, and in a similar way that like Hawking had done with the Big Bang or with black holes, and show, all right, well, actually, if you project things back, it goes back to a singularity, which is basically say, there is a limit to how far back you can go. That Borde-Guth-Vilenkin argued from their theorem that if you project things back just using general relativity, inflation can't go back infinitely far back in time. They also showed that even if you account for the effects of quantum mechanics that we know about well, effects from the other fundamental forces, and put that in there, it's still the case that you can't have inflation go back infinitely. There'd be some sort of finite limitation. Okay, so then Craig is basically saying, well, since inflation can only go back a finite amount of time, therefore this is evidence that the universe had a beginning. For one thing, that doesn't even necessarily follow. I mean, it even reminds me of one of the arguments of Kent Hovind, who's obviously a bastion of correct information, right? He was trying to argue and say, hey, the Sahara Desert is only a few thousand years old. There's no way the Earth can be millions of years old. No, it's just the Sahara Desert's a recent formation, not that the Earth is a recent. It doesn't follow at all. I mean, you could still have a universe and just not have inflation going. So it's not even a necessary, conclusion or the only logical conclusion from a beginning point of inflation. So just from that straight logic point, but the real thing is, okay, how robust is this theorem? I've looked at the paper, and I don't think you're going to shake it on its own grounds. You're not going to say, they missed a 2 or something like that along the way. But there are a couple things that one could point to. One is that while it does account for the quantum mechanics we understand well, it doesn't take into account quantum gravity because we don't know how to do that yet.
Right.
Maybe it's possible that once we incorporate that, we can again project inflation back indefinitely. I don't have the skill set to really say if that would happen or not. So rather than, of course, say, well, here's something we don't know to get an answer we want, let's just take it as is. Let's say it's reasonable to conclude from the theorem that inflation can only go back indefinitely. But there's also one assumption that is made in the paper, is that the inflation effect is it would always on average be expanding. So that basically it's always, trying to make things bigger. Maybe not as fast as other times as others, but, on average there should always be some expansion. Well, in that case, you could have, you could go through options. Okay, well, maybe suppose that the inflation will go back and forth. Sometimes it's expanding, sometimes it's contracting. That would get around that theorem. And you could have some sort of cyclic universe system. Or basically you could say, all right, you project inflation back to some finite point in the past. And then before that, it's in some sort of crunch phase, and then you can project that backwards indefinitely. So in our time frame, basically, you would be going backwards, and you'd see the universe getting smaller and smaller and smaller and smaller until you get back to basically the beginning of inflation. And then if you go past that, then the universe is getting bigger, but in effect, this is now actually the contraction phase, because you're going backwards in time, and yet the universe is getting larger backward in time. So that would look like the crunch phase. If you put in this sort of symmetry then of what would look like crunching to us in the past, but then inflation forever into the future, we could still then have an universe infinite, both past and future, and still be consistent with the same theorem. Vilenkin has said the same thing himself. Victor Stenger, the late physicist had asked him about this and said, yeah, if you basically said, okay, just have a contraction phase before the inflation phase, then you would get past the finitude of what the theorem would project. So it is not that rock-solid proof that Craig and others want it to be.
Yeah, I've heard them make assertions in debates before that this is something that should be true independently of any discoveries about a theory of quantum gravity, but I've yet to actually hear an argument made in defense of that. So I don't know really how far we can talk down that avenue in this. But so on that subject, kind of moving on a little bit from that, are there any current developments or work in cosmology that kind of has you excited for what it may shed light on in the future about specifically the topic of origins?
Well, I mentioned inflation before, and I should talk a little bit more about what this was. It was actually first developed to try to explain what were actually problems with the original generic Big Bang theory. Because one of the issues you have is, all right, well, if you look out at the universe at the largest possible scales, especially if you're looking at the cosmic microwave background, you're going to notice that it is amazingly even. When I say amazingly even, that actually if you looked at the variance in the temperature background of the cosmic microwave background, the variance is only 1 part in 100,000. This would be like if you had something smooth like glass. That's how smooth the universe seems to be. And the problem with that is that that's impossible with just the regular rate of expansion for the universe. You'd basically, in the same sort of way that if you had a balloon filled with air and you popped it, it would take some amount of time for the air pressure inside that balloon to equalize with the air pressure outside of it. Well, we can figure that same sort of thing out. If we look at one region of the universe and another, they would have to have enough time to interact with each other so they would come to the same temperature and reach equilibrium. And the universe isn't nearly old enough for that to have happened across the cosmic microwave background. So this is this isotropy, this equality, this equalness of how the universe is spread out on the larger scales is not well explained on regular Big Bang theory. The other thing is also that the geometry of the universe, which ultimately tells us whether the universe is going to expand forever or if it's going to eventually stop expanding and contract again, is dependent on ultimately the geometry of the universe. And the geometry we have seems to be extremely close to a very particular value that says the universe will exist, last forever, but it's like we're going at escape velocity, that somehow I took a baseball and I threw it up exactly at escape velocity, no faster, no slower. How do you get something that almost fine-tuned to that amount? Inflation is basically coming in and saying there's this exponential expansion of some region, and so it expands it out really fast, and if you have just some tiny region you spread out really fast, that's going to make it really smooth. And because of this expansion, it's again like if you were inflating a balloon really, really fast, the surface of that balloon would look very flat to you. If you had a balloon in your hands and somehow you were able to make it expand to the size of the Earth very quickly, it would look like a flat, it would look like a flat Earth to you. That's the basic idea of what inflation is, but on extremely small time scales and using grand unified theories of physics. So why is this important? Because it's also not just explaining these interesting cosmology questions, it also then might be the sort of way that universes kind of just pop themselves into being and even creating multiverses. Right now, most cosmologists think inflation is true, but it's nowhere near as well evidenced as the Big Bang theory. But there are efforts to, better understand it, either just theoretically or even doing measurements. So I think it was last year, there was the announcements of BICEP 2 down in Antarctica, and they had thought they had seen these particular patterns from the cosmic microwave background based on certain light polarizations that were supposed to be indicative of gravitational waves or gravity waves from the early universe.
Yeah, I remember those announcements getting spread all over Facebook when that came out.
Oh yeah, it was huge news. The announcement was dropped by one of the inventors of inflationary theory. Him coming to tears with his wife. It was this heartfelt thing, and then you find out, it might be the case that this can be just explained by dust. But But there's continuing efforts to try to do this measurement better, do it with different technologies, may have to upgrade equipment or just a whole new project. But this sort of thing, these sorts of detections are also something that would be expected from inflation. And if we have better measurements of inflation, well, first off, we'll know better that it exists. And secondly, we'll have an idea of, this would actually boost the idea of eternal chaotic inflation and the multiverse theory. So, I mean, just think about that. Looking very carefully at light from about 13 billion years ago, and just noticing how it kind of swivels around a little bit with these polarizations of its light. Very careful measurements of that could tell you that we are one of an infinite number of universes. If that doesn't make you want to get out of bed in the morning and look at science news, I don't know what will. So, that's a big thing. I don't know if it's going to happen anytime soon, but maybe in the next 5 years we'll have better measuring equipment.
Well, I've heard that they're going to be maybe doing another Cosmos season, so maybe, who knows, they can work that in there sometime, and we'll see. So you've published a book on the Star of Bethlehem and the astronomy implied by the story. As a cosmologist or a physicist, what made you pick such a specific issue, and especially one that, I'm sure there's lots of people who do view it in a literalist fashion, that there was this actual star that guided them there, but there's probably a whole lot of religious believers and Christians who also view this as kind of like an anecdote, or maybe anecdote's the wrong word, but as kind of a story that has a bit of a different meaning to it than an actual star that guided them to the I think it was a manger in the story, or I know it was a house in another one, but anyway.
Yeah, in Matthew's account, they come to a house. In Luke's account, he's away in a manger. And in other accounts, he's in a cave.
In a cave, yeah.
Yes. Because I think he's actually Batman. Maybe that's another story. All right.
Well, I hear that Batman's not such a great savior to have, according to the Christopher Nolan movies, but oh well.
He may not be the one we deserve, but he's definitely the one.
Exactly. So what made you decide to write a book on the Star of Bethlehem, of all things?
Just my sheer hatred of Christmas.
So you're the one involved in this war on Christmas I keep hearing about.
I sleep under Bill O'Reilly's bed and I just try to scare him. No. That would be a terrible use of my life. Okay. Ultimately, I had discovered this sort of thing going on when I was at Michigan State my freshman year. I was actually working as a show presenter at the planetarium at that university. And has been tradition there, and pretty much planetary all across the world, is that around Christmas time, you have a seasonal holiday show that, in part it's going to talk about, why do we have seasons, but one of the big features of it is astronomical explanations for the Star of Bethlehem. And this has actually been true for an amazingly long time. I've done some of the history research on it recently, and apparently it goes back to the 1930s where these sorts of shows are being introduced and have become popular in not just the United States, but even in Germany and France, etc. It's all over the place.
Wow.
It's basically a tradition. Even though probably a good chunk, maybe even most of the planetarium workers know that the theories don't even really work, but they bring in audiences. They don't want to come up with a new show. It's still teaching them some astronomy, they think, and the Star of Bethlehem to them just becomes known as the SOB. Yes, I learned that as a planetarium worker, and when I had at least one tiny interaction with Neil deGrasse Tyson, he said the same sort of thing. So it's well known amongst all the planetarium folks. But I first learned about it then, and it's like the hypothesis that was being presented the first time I'm seeing the show. I'm like, oh, that is interesting. Wow. And at this point, I'm still nominally Catholic, but hardly literalist or anything like that. But then I also remember going home for the holidays and it being a special on TV, and it's like, oh, that's interesting. That's a different hypothesis. There's more than one? What's going on here? And then I then start digging and finding out, oh boy, has this been going on for a while? And when I say for a while, there have been literally 200 years of attempts to correlate something with astronomy or astrology to the story from the Gospel of Matthew. And I realized, this is in science education. That's something I'm interested in. Specifically, my Ph.D. in physics is geared at science physics education. So that's kind of my thing. This is in planetaria. I mean, these are meant for the education of the public. And I discovered that, there's all these competing hypotheses. None of them really seem to fit the data better than others. The Bible scholars have been saying something different for the last 150 years. Also, the people who are making the arguments generally can't read the original language of the gospel and sometimes make amazingly absurd statements about the Greek that somebody in their second week of Greek class would realize is wrong. And I can say that with authority because I literally saw something wrong after 2 weeks of taking Greek class. So I realized, okay, I need to, really dig into this, figure out what's going on, and try to get the truth out there. Obviously, I have the only truth. And so
is the hypothesis, or I guess there's multiple ones of these, but so this may not even warrant a question, but is it that they're trying to just kind of come up with a maybe, could be, this could happen sort of explanation for this story that's in the Gospels? Or is it more than that? Like, is this they're trying to actually, identify a star that they believe was the Star of Bethlehem?
Some are going to use the approach and not only, say this is possibly what the star was, but actually use it to date the birth of Jesus.
Oh, wow.
And in particular, some of the recent work in trying to use an astrological theory will basically produce a horoscope for him, which also requires knowing the particular hour of birth. Even if it doesn't happen to have been, the horoscope written up by the Magi, the wise men of the story, if it was somebody, making it up afterwards and projecting it back. Somebody claimed to have known the hour of Jesus' birth, if that were the case. And then people are trying to do that and figure out, okay, when precisely was Jesus born? One of the names that actually gets attached to this most often is the German astronomer Johannes Kepler. He had written about this subject, in particular he had written this large treatise trying to basically fix world chronology, and in part using astronomy, in part using historical arguments. In part he was influenced by people redating the death of King Herod, because most people figured, well, Jesus was born in 1 BCE at about midnight on December 25th. So Herod had to have died sometime after that. But then people were realizing, a more careful reading of Josephus would say, actually, Herod couldn't have died any later than 4 BCE. So we need to fix the dating system and say, all right, somebody just goofed on that. So that's part of the reason Kepler got interested in that. And also, Kepler was an astrologer, and he was using his own astrological theories to try to understand what the Magi would have been interested in. A supernova had gone off in 1604, close to this conjunction of Jupiter and Saturn, that had been of great astrological interest, and then was trying to project that back to what the Magi might have been thinking. So, I mean, in some ways you could say, this has an even longer tradition of 200 years. This goes back to 1614. Though Kepler himself said the star was actually a miraculous object that floated around the atmosphere and basically, produced the Eat at Joe sign to the wise men to see where Jesus was supposed to be. He obviously didn't use that particular vernacular, but that sort of thing. Believed it was a miracle, but used astrology to say why the wise men would have been interested. But in general, for modern folks, some of them are just producing kind of say, here's the diversity of ideas. So there must have been something going on back then. And others saying, there was definitely this, and now we can certainly date when Jesus was around and use that to authenticate the gospel. Praise Jesus, hallelujah. Others, of course, will look at it and read it more literally and say those don't work, or at least point out the various limitations of the astronomical theory. Perhaps one of the more interesting studies on this was actually by the great Catholic scholar Raymond Brown. And when he, approached it, he said, well, really nothing in astronomy really fits a literal reading of the gospel, but saying, well, the astronomers don't really take everything literally, so there's kind of a range of options. Unfortunately, that isn't even quite true, because there are a number of astronomers saying, this particular word from the gospel, this is actually an astronomical term, so they're even taking it more literally than, or think they're taking it more literally than even the translators of the Bible. Unfortunately, they can't read Greek and they're wrong.
Well, on the other side of the fence, I know there's been multiple occasions, different people within the atheist community have made comments about how scientists and biologists specifically shouldn't bother debating creationists because they think it just gives them the appearance of actually having a good argument and stuff. But do you think it's important for those in the scientific community to kind of like you're doing, speak out on areas where religion overlaps with science and with your work in the field?
Well, I think it depends on how big my honorarium is, doesn't it? But quite seriously, when people, for example, were arguing that Bill Nye shouldn't have done the debate he did with Ken Ham because of the reason that seemed, rather valid, you're just going to give them credibility. The problem is, though, for about half the country, they already think Ken Ham and others like him are the credible ones, and Bill Nye is the one who is on the outs on the science, let alone the religion aspect of things. When you actually have such a big portion of the country that really believes that sort of thing, then I think we are obligated to confront it openly. We can't really give credibility to it because it already claims to have had it. On the other hand, if we were to say argue with flat earthers, because I can't even believe 1% of the population of the U.S., for example, honestly believes that the Earth is flat. They might say it to a pollster because you're messing with someone, but it's probably, so small that if we were to argue it, it would give it, more notoriety. I don't think we can do that with creationism because it's being taught in schools, no matter how much we've been trying to prevent that. I feel that, if anything, our hand is being forced, and we need to get out there and fight the good fight.
Yeah, and that was one of the things that I heard a lot of the criticism, speaking of that Bill Nye and Ken Ham debate, was that Ken Ham would get a whole lot of money out of it, which he did, and maybe he got more money than he would have otherwise, but he's still going to wind up going bankrupt trying to build that crazy ark. That's just, I mean, I do think that there's some usefulness in that. And there's a lot of people out there, even sadly among some of my fellow atheists, I think, who have this view that you're never going to change anybody's mind. People just don't change their beliefs. Well, I mean, speaking, as a personal story here, I changed my beliefs somehow, and maybe it wasn't exactly through, a formalized debate or anything like that, but I do think there's something to be said for just kind of like occasionally chipping away at the things like that are there, and I think it is important to actually speak out on this stuff, just because even if you can erode some of the slightest misunderstandings, that counts for something, I would argue.
And I would agree with you. And besides, the argument that, well, you'll never change anyone's mind, or you'll change very few people's minds, is just kind of in denial of the evidence of the fact that people are, even if they're not becoming atheists or agnostics, they're kind of flocking away from the most fundamentalist or most problematic forms of the religions. I mean, nuns are growing like crazy, and it's, of course, not because the Methodists are, chasing people out. It's science denial, it's gay bashing, it's things that make it look like we're trying to go backwards in time. So
yeah,
it's somehow, some way, there is this evolution happening. Is it all because of arguments, because we're all brilliant debaters? Well, if YouTube comments are anything to go by, it's probably not that.
Well, I can't wait for the ones I'm going to get on this when I post this on YouTube.
First.
So tell us what you have coming up in the future. Do you have any more books you're going to be publishing, or debates or articles or anything exciting to you at this moment?
All right. Well, in the pipelines right now, related to the Star of Bethlehem, there's a few things. One is, last year I had participated in this big academic conference on this subject matter, which had experts in astronomy and history and New Testament studies. And the book...
See, that seems like it says something in itself that there would even be an academic conference on something like that.
Oh, yeah.
I guess this is a bigger issue than a lot of people realize, it sounds like.
Well, it has a really strong pedigree, and in particular, the hypothesis we were arguing about was published in a book from a university press that has been getting a lot of praise by pretty big names in like history of astronomy, including, particularly the hypothesis we were talking about was developed by retired astronomer Michael Molnar. It had gotten endorsed, for example, by Owen Gingerich of Harvard University, who's probably one of the top historians of astronomy in the world. So, a pretty good blurb. So, I mean, it was, even though I obviously disagree with it, and I think I torn apart every single piece of evidence for it, ego aside, it was worthwhile having this discussion and seeing, okay, what actually would be an adequate hypothesis and what is the best. In my book on the subject matter, of course, I argued that it's fiction, astronomy doesn't actually fit things, and ultimately it's based on mythic or literary tropes. And it's still worth arguing what is actually the best literary tropes. In fact, at the conference, that's one of the things is, what best explains it. Is it a citation of the star prophecy from Numbers 24:17 in the Old Testament? Or is it something from one of the proposals was actually related to the conquest of Alexander the Great in Babylon. So there's still things to be argued there. I've also put up my own ideas of resurrecting the form of the argument based on the leading star of Aeneas from the epics of Virgil. All the good stuff. So plenty to be argued there. That's one of the reasons this conference needed to happen. So my chapter a chapter will be in a book coming out later this year from that conference, and there'll be lots of things worth reading, even though only my chapter is the most worth reading. So, lots of important things by people who are absolute experts in the Parthian Empire in Persia or Greek astronomy in that period, etc. Things that are just going to be must-go-to things if you have any interest in the subject matter, or even just ancient science, because while astrology, we consider poo-pooed, it was being treated and acted out as if it were a science, and you really can't understand ancient astronomy without understanding astrology. So that's in the pipelines. Currently, I'm also in a book project on two other things that might still come to fruition. One is, there was this exhibition called 1001 Inventions that actually got a fair bit of play on YouTube, people criticizing it. It was ultimately this thing trying to show, how innovative the Islamic world was during the Islamic Golden Age and all the science and technology and cultural things that had developed then. Great idea, but the execution of it was both flawed in the information it presented when it was saying, oh, these are Arab or Muslim inventions, even if they might have been invented by the Babylonians 1,000 years earlier, the Greeks centuries earlier, things like that. Or just in general that it has this sort of incorrect view of how the history of science even works. So I have a chapter in that basically saying, all right, how do you actually properly do history of science education in a museum format? Hopefully that'll come in the future, but it's still in the back burners. And more recently, let's see, John Loftus is apparently trying to come out with a new book in his series of books that are kind of copying the new atheist books. There was the Christian Delusion, Christianity is not great. He's now trying to come out with one that's basically about science and Christianity butting heads, and I'm hoping to have some say in that, in part with my stuff on the Star of Bethlehem, because it's what I've spent over a decade on. And
I've been wondering if he does one kind of modeled after Breaking the Spell. What's he going to title it? Like Breaking Christianity or Breaking the Christian Spell or something?
Spelling the Christian, spelling Christian, that's not something I can do. I'm terrible at spelling. That's why I went to physics. Then because I can't draw. But so that's supposed to be something in the pipe works, and I can't give you a timeline for that, but I'm sure you'll want to buy 2 copies, along with my book, of course.
Well, very cool. So if anybody wants to find out how to get a copy of your book or find out more about you, where could they do that?
Well, Amazon, of course, has probably the easiest access to the book in both physical and electronic copy format. I have a Facebook and Twitter account. I have a blog titled Fleeing Nurgle, Seeking Stars. Website is gilgamesh42.wordpress.com. I have way too many Sumerian references in that title, but I do, while I love astronomy and I also love history and ancient myth, and so I gotta go with the oldest one, the Epic of Gilgamesh. Hurrah.
Well, from what I've heard, the Sumerians are kind of tied in pretty closely with a lot of that ancient astrology and stuff like that.
Oh yes, yes. I mean, when you're the first people to, make writing and do some amazing, basic astronomy, to figure out things like centuries before the Greeks did, like the morning and evening star are the same object. Sumerians figured that out. The Greeks didn't figure that out until millennia later.
Well, Aaron, thank you so much for coming on the show.
Thank you. It was an absolute pleasure.
I'd like to thank Professor Adair for coming on the show. If you'd like to find out more about him or purchase his book, links are available in the description for this episode at godlesshaven.com. At godlesshaven.com, you can also find out more about the show, more about myself, and plenty of additional content. Music in the show is my own work. Thank you for listening, and please join me again in the not-too-distant future for another episode of Armchair Atheism.